In this video, I want to show you how to run a linear regression on the calculator and also how to answer some questions that come up in conjunction with that. The problem that I'm using as an example is taken from section 4.2. It's problem number 31 and it's found on page 222 of the text. As you can see, I've already taken the time to key in the data from that problem here. Just a word of advice, it's typically understood when you do a linear regression that list 1 is reserved for the x values, in other words the explanatory variable, and list 2 is reserved for the response variable, aka the y values. So to run the regression, first thing you want to do is go to the Stat menu, go to Calc, and function number 4 there, linreg, which is an abbreviation for linear regression, is the one we want. Now this particular function defaults to list 1 and list 2. It assumes x values are in list 1, y values are in list 2. If you want to tell it some other lists, you can do that. The syntax would look like this. We can just tell it list 1 and list 2 here. We'd say second list 1, comma, second list 2, and then press enter and it will run. Now what you can see here on the screen is as follows. You can see the slope, a. You can see the y-intercept, which is b. You can see r squared, which is known as the coefficient of determination. It's covered in section 4.3. And you can see the r value here, which is the coefficient of correlation, and that's covered in 4.1 and 4.2. Now, we want to do a few things here. Let me follow along with the question to make sure I'm answering all the parts. The first part of the question here says, which variable is the explanatory variable? It's part A. That would be the x values, the ones we stashed in list 1. It asks us to draw a scatter diagram or a scatter plot of the data. Now we can have the calculator do it for us. It's not hard. To do that, you'd go to the Stat Plot menu and pick one of the plots. Let's turn on plot number 1. And that right there that's flashing is the icon we want for a scatter plot. So press enter. And you can see it's going to be looking in list 1 for the x values and list 2 for the y values. Now to get it up on the screen, you can just hit zoom 9. And right there is the scatter plot of your data. Now you probably could clean up the window a little bit. When the calculator picks the window size, it's usually some strange number. So let's just round this off here, make it a nice 1,000. And for that one, let's round it up to 1,700. You want to have a little bit of breathing room around the data set in order to answer the questions that we're going to be getting here in a minute. An x scale of 1 is way too small, so let's change it to 100. And then for the y values, let's go from, say, 140 to 200. And let's make the y scale 10. And now when we graph this, we have a nice looking window with nice hash marks and everything like that. Now it's very helpful to have the regression equation superposed over this scatter plot. And to do that, you can go to the Y memory register here. We don't want you to retype that regression equation. There's no need to. You can just get it from the calculator. You go to the VARs menu, you go to number 5, and you go over here to EQ, which is abbreviated, it's the abbreviation for equations. And you can see the first thing that's highlighted right there is the RegEQ. That stands for regression equation. So just press enter, and you can see that it will store the regression equation for you in y sub 1. So now if you go back to the graph, you have not only your scatter plot, but you also have the regression equation graph for you right there. Now, the next thing that is being asked here, it says in part C, determine the linear correlation coefficient between the square footage and the asking price. Let's quit this here. Let's clear that and see what we have on the screen here. We need to go back actually and get that. So I'm going to run the regression again, just to have it pop up on the screen. Remember that command defaults to list 1 and list 2, so just press enter. The R value right down there at the bottom is your correlation coefficient, and that's a nice one right there. It's fairly close to 1, so it indicates a positive correlation. It also indicates that the data is fairly linear, and as you can see that in the scatter plot. And so in part D it says, is there a linear relation between the square footage and the asking price? Most definitely. As you can see, we have a high correlation coefficient, and we also have a very clear visual representation of that. Part E says, find the least squares regression line treating square footage as the explanatory variable. Well, we did. It's right there on the screen already, and we even have it saved in the y sub 1 memory register. Part F of the question says, interpret the slope. Now this is a little tricky. You probably want to look at the mock exam for some practice on that. A lot of people struggle with this, and one of the reasons is they don't stop to think, what are the units of measure that would be attached to the slope? It turns out that they're the y units divided by the x units. Now in this case, the y units are thousands of dollars. It says that in the book right there at the top of the data set. And the x units are square footage, or square feet. And the slope is in kind of an inconvenient form. If you see right there, it's 0.68597 blah blah blah. If you wanted to round that, you could say, you know, it's more or less around 0.07. And even that's tricky because it's basically saying that the price of the house is going to increase by about 7/100 of $1,000 for every 1 square foot increase in the size of the house. And that's quite a mouthful. It'd be a lot easier if we could get that ratio in something, you know, like a more user-friendly form. It can also be written as 7/100. And so you could say that for every 100 square foot increase in the size of the house, the price of the house is going to go up by about $7,000, something like that. Anyway, you got to practice that. Part G says, is it reasonable to interpret the y-intercept? There's a bit of a typo there in the text, but that's what it's supposed to read. Is it reasonable to interpret the y-intercept? Well, you could, yeah. The y-intercept is right here, and it's nonsensical, but you could give an interpretation. Whenever you're interpreting a y-intercept, or an x-intercept for that matter, you always want to think about what does the 0 coordinate signify in that context. Because whenever you look at the intercept of a linear equation, one of the coordinates is always 0. In the case of the y-intercept, the coordinates of that would be 0, 83.236, blah, blah, blah. And that 0 signifies square footage. So basically what we're saying is that according to the model, the price of a house with 0 square feet, aka an empty lot, would be, you know, $83,000, something like that, right? So you'd pay $83,000 for an empty lot. It's nonsensical because it's extrapolated, but that often happens when you're interpreting these kinds of things. It says in Part H here, one home that is 1,092 square feet is listed at $189,000. Is this home's price above or below average for a home of this size? What might be some reasons for this price? Well, what they're really wanting you to do is to use the regression equation to see what would the price be of a home of that size. Now, you don't see one in the list, so what you need to do is to go back to the graph, and we want to input a value and find out. So the best way to do this would be as follows. You can go second trace, and you can see number 1 right there allows you to input a value. So the square footage they're asking about is 1,092. Let's put that in and see what the price according to the model would be. Now you can see right here at the bottom of the screen it says that it should be 158,000 and some change. And in the problem it said that home was listed for 189,900. And so they want to know, is that home's price above or below average? Well, it's very much above average. The average price is what the model is giving us. And why would it be above average? Well, you know, there's a lot of reasons that a home would be more expensive than the average. You know, it could have a really nice view. It could be in a really nice neighborhood or a highly desirable area. It may have some nice features like a swimming pool, or who knows. But there are a lot of reasons that that could be the case. Now, the other thing that we'd like to show you, this is the final example here. One of the questions that we typically ask is, if we give you a y value, can you find a corresponding x value? So in other words, if we gave you, in this case, the price of a house, that's a y value, we want to know, could you use the model to find what the average price or the average square footage would be? And so the best way to do that would be as follows. This is not asked in the text, but I'm just giving this as an extra thing here. Let's say we want to know what would the model say the price of a house that's $175,000. You know, if the house is $175,000, how many square feet should it have? Well, best way to do that would be to go back to the y equals register here, and let's go down one, and let's put in 175. which would represent 175,000. It's going to be a horizontal line. And so when we press enter and go to the graph, you can see that line now. And basically, when we give you a y value and we're asking for the corresponding x value, we're really asking you to find the intersection of those two lines right there. And the best way is to have the calculator do it for you. And so you can do that as follows. You go to the second trace menu again, and you see choice number 5 right there is intersect. So you take that one, and it's asking you, what do you want to use for the first curve? Well, I want to use the regression equation, so I just press enter to affirm that. And then it wants to know, what do you want to use for the second curve? Well, I want to use that horizontal line. So again, I'll press enter to affirm that. And then it says guess, and it wants you to get the cursor somewhere in the neighborhood of the intersection. Well, you can see the cursor flashing right there, and it looks like it's pretty close, so I'm just going to press enter. And now you can see that the calculator coughs up right here that the square footage should be about 1337 and some change. And so that's the best way right there to find an x value if you're given a y value. And the problem that we answered in part H there is how you would approach when you're given an x value and you're asked to find the corresponding y value. Hope that helps.